Welcome back, guys. Patrick here, and moving on to the next question. We got to find this limit here. The limit as x approaches 2 of the absolute value of x minus 2 times sine of 10 over 2 minus x. So notice with this particular limit, we can't do a direct substitution. If we plug in 2 for x, this would be 0. That's fine. But notice here, we're going to get a denominator of 0. Can't be dividing by 0. So we got to use some kind of other strategy. And notice in this particular case, we can actually use the squeeze theorem, because notice that this sine of 10 over 2 minus x, that's always going to be in between -1 and +1. Right? Sine of any expression, cos of any expression, it's always got to be between these values here. As long as there's no addition here and there's no other coefficient in front, right? If it's just sine of an expression or cos of an expression itself, that's always going to be between -1 and +1. And so we took this part, wrote this inequality out, and what we can do now is we can bring in this absolute value of x minus 2, multiply it here, here, and here. So what we would end up with is negative absolute value of x minus 2. That's less than or equal to the absolute value of x minus 2 sine of 10 over 2 minus x, which is less than or equal to the absolute value of x minus 2, like that. Now, how do both of these functions look? So the absolute value of x minus 2, that just basically looks like that. You know what? Let me shift it a little bit more. It looks like that, right? At an x value of 2, we would have a y value of 0. Now, how does negative absolute value of x minus 2 look? Well, it would just be this graph reflected in the x-axis. That a value is negative, so it would just look like this. But it would still have that 0.2 and 0, like that. Right? So since we know this inequality is going to hold, because we know that this expression itself is always going to be between -1 and +1. It can never exceed that boundary. Then we know that this expression is going to be between these values. So since that inequality holds, and since the limit as x approaches 2 of absolute value of x minus 2, it's actually equal to the limit as x approaches 2 of negative x minus 2. Notice that both of them, they're going towards that y value of 0. Right? So since this inequality holds and both of these limits equal 0 as x approaches 2, then by the squeeze theorem, what that means is that the limit of that function as x approaches 2 is also going to equal 0. Right? Because if we combine these two graphs, that absolute value x minus 2 and negative x minus 2, they're going to look like that. And so this function always has to be between those two functions or equal to them. So notice that this x value of 2, well, there's only one y value that this here can approach, and that y value is 0. So since this inequality holds and both of these limits equal to 0, then by the squeeze theorem, the limit of that overall function is equal to 0 as well.